Welcome to today's lecture. Before we start with the lecture, let me review the topics that we have covered. So far, we have started our lectures this semester with defining some key terminologies. Then we have moved on to statistical process. Specifically, we have considered different steps that we need in order to perform a statistical project. Which starts with specifying the questions that need to be answered using data. After that, we have to specify the population and the statistical variables of interest. Then we collect data on those variables of interest, either from a population or from a sample. After collecting data, we manage and clean our data, and then we start with the analysis. In the analysis step, we have started with univariate descriptive techniques. Namely, we have seen how to construct frequency table. We have studied graphical techniques, and we also introduced numerical techniques. In numerical techniques, specifically, we considered measures of location, such as mean, median, mode, quantiles, and percentiles. Measures of variation, such as range, interquantile range, mean absolute deviation, variance, standard deviation, and coefficient of variation. And then lastly, we have seen the measures of distribution, namely skewness and kurtosis. Next, we will study how to standardize a given statistical variable. A statistical variable z or z is said to be standard if its mean is 0 and its standard deviation is 1. Standardization is a key concept in many applications in statistics and probability theory. We will see that in later lectures. Particularly if we are interested to compare the distribution of variables having different mean or different center, we try to standardize them first, then compare. Almost all variables we are dealing are not standard at the beginning. If we have a statistical variable x, whose mean is m and standard deviation is d, then how we standardize it? We subtract from in each observation that we have collected on x, we subtract the mean and divide that difference by the standard deviation. That is, z is equal to x, which is the statistical variable, minus the mean of x, which is m, divided by standard deviation of the variable x.